Hey everybody, and welcome back. This is class 15. We're going to look at other types of polynomial functions beyond just cubic functions, which is what we looked at in the last lesson. So the objectives for today, we're going to look at degrees of polynomials. What does that mean and how do we figure it out? Write the equation of polynomials based on given roots. So if we're shown a graph or we're told what the roots of a polynomial are, that we can write the actual equation or function for it. And then we're going to sketch graphs of polynomials. And the word sketch is in there because it's going to be an approximation. We want to show the general shape with the actual accurate roots, but we're not necessarily as concerned with the turning point. So it's going to be a sketch as opposed to actually graphing the polynomial. And then we want to identify key parts in a polynomial as well. Essential questions for today: how do I identify the roots? And write it in factored form. What is the degree of a function? How do I determine it? And then what does this word multiplicity mean? So that's something that we should be able to answer by the end of today. In the last lesson, we talked about cubic functions. I looked at transformations on them. We're able to write the equation of a cubic based on the graph if we were given the point of symmetry and one other point. All right, degree of polynomials. So when we talk about the degree of a polynomial, it's not necessarily something you're going to get asked about in today's homework, but it's something that's going to pop up a lot in the coming weeks. We may see it again later, and I'll go through it again at that time, but I want to bring it in now so that we had a good idea of what I was talking about. So when you are looking at any expression, so remember, an expression is just a set of terms that contain numbers and algebraic letters, and we look at the exponents, and based on the exponents, we determine what the degree of a polynomial is. So the degree is calculated based on the sum of the exponents on every term. So I'll show you what that means in a second, but think of sum adding exponents, so raising something to a power, and then of each term. So that terms are the parts of an expression that are separated by addition or subtraction. So for example, if we had a to the power of 4 plus 4a squared b plus 6a squared plus 4ab plus b plus 5, I would ask you, what is the degree of the expression? And you would have to try and figure that one out. So how we do it, we look at a to the power of 4. Okay, it's just a, it's raised to the power of 4, so this has a degree of 4. The second term is the 4a squared b. A is to the power of 2, b is to the power of 1. Added together, that would be a 3. So just be aware of that. This is not just a squared because that's the highest number. We take the exponents of the term, so every variable in the term, add those together. 6a squared, that's an easy one, 2. A to the power of 1, b to the power of 1, also a degree of 2. B to the power of 1, and then 5. So we'd have 4, 3, 2, 2, 1, 0. The degree of the whole expression is equal to the highest individual degree. So that, in this case, that would be the 4. So a to the power of 4 has a degree of 4, which means the whole polynomial or the whole expression has a degree of 4. Side note, any numeric value has a degree of 0. So there's no variable not raised to any exponent, so it is a degree of 0. Even if you get something like 5 cubed in your expression, well, you can evaluate that as 125. It still has a degree of 0. So just be aware of that. So when we add or subtract polynomials, the degree can change. When we multiply, the degree can change. When we divide, the degree can change. So just quick recap from Algebra 1, if you are adding polynomials, you can only add terms with the same degree exponent. So it has to be the same letter combination, and they have to be raised to the same power. So when we look at this, there are x squareds, there are x's, there are x cubes, and then there's x to the power of 4. So there are, and then there's also the constant 5. So there are different degrees of x all throughout this. There's only 2 that match, and that's the x squared. So when multiplying, it's a little bit different because you are doing distributive property and then combining your terms afterwards. So distributive property, Now, it can be any number of terms inside of the parentheses. So this is the distributive property. So not thinking FOIL anymore. It's everything in the first parenthesis times everything in the second. If you lob a third parenthesis on the end, you do the first two first, get a new expression, and then multiply that by x plus 3. So you're just doing it in order that way. So if we just take an example, 3x squared times 4x cubed. So if you break that down, 3x squared is 3 times x times x. So we're putting it into its individual factors. 4x cubed is 4 times x times x times x. 3 times 4 is 12. So when we're doing this, the 3 and the 4 multiply. And then the x's, you have 2 in the first, 3 in the second. That will be 5 x's multiplied by itself, which is where x to the power of 5 comes from. So this is a law of exponents, that when you do x squared times x cubed, it's the same as x 2 plus 3, so x to the power of 5. So just be aware of that. If it's x squared plus x cubed, you cannot do anything else with that. It's done. So multiplying, you combine the exponents, adding, subtracting, you do not. So if we take this example, 2ab times 3x plus 4ab squared, we would do 2ab times 3x and 2ab times 4ab squared. That would give us 6abx and 8a squared plus b cubed. And now it could be like, well, what's the degree of this expression? So now that we've combined, so let's see, 2ab, 1, 2, so that had a degree of 2. 3x had a degree of 1. 4ab squared had a degree of 3. So 6abx has a degree of 3. 8a squared b cubed has a degree of 5. So we would say, okay, well, it went from 2 and a 3, so a degree of 2 and a degree of 3 to a degree of 5. So coincidence or not that they were added? Maybe you'll find out in the future. I want you to try and figure that out. Is it always going to be the degrees added when you multiply two different expressions? All right, so your turn. Subtract, multiply, add, and then also write the degree of the solution. So you're going to find the solution. So combine like terms, put it in degree order. So you should put it from highest degree to lowest degree in terms of the terms. And then what is the actual degree of the expression? So pause the video, try it out, come back. Okay, let's take a look. So we know when we do subtraction, we have to distribute the negative to every term that's being subtracted. So this would be 3x minus 5y minus 6x plus 2y squared minus 7. Things that can be combined are the 3x and the minus 6x. The highest degree is 2y squared. It has a degree of 2. So that's going to go first in my answer. So 2y squared. Degree of 1 would be our x's and our y's. So it doesn't really matter which one we put first. I'm just going to put the minus 5y in there. 3x minus 6x is minus 3x. And then we've got minus 7 with a degree of 0 goes at the end. Total degree, highest one is 2. So this has a degree of 2. And you can put it in a box at the end. I will know what you mean. Just make sure you're not putting like x equals 2 or something weird like that. Like it's 2 and you can either label it. So degree equals 2. You can put 2 with a box on it, something that just lets me know, okay, that is a separate value to the equation. That's me identifying my degree. Second one, distributive property, 15ab times 2a squared. 15 times 2 is 30. A times a squared is a cubed, because now you'd have 3 a's being multiplied. And then b, there's no other b in the second one, so it would be 3a cubed b. 15ab times c. So 15 times 1 is 15. A and b have nothing else to multiply with, and c tucks in at the end. So we get 15abc. 6cd times 2a squared. So we get 6 times 2 is 12. Now you don't have to put the letters in alphabetical order, but it's a kind of a nice habit to get into. So we'd have an a squared because it doesn't combine with c or d, and then cd would tuck in at the end. And then finally 6cd times c is 6. Now c times c is c squared, and then there will be a d at the end still. Identify like what their degrees are. So 3a squared b to the power of 1, that's a degree of 4. A, B, C, degree of 3. Squared 1 1s, that's a degree of 4. And squared 1 is a degree of 3. So we've got a degree of 4 for our actual equation. Now we just need to put this in the correct order. So there's two terms that have a degree of 4, so they go at the front. So we got 30a cubed b. Doesn't matter which one goes first, you just get to pick if they have the same degree. A squared cd. And then same thing with the degrees of 3, doesn't matter. So 15abc plus 6c squared d. And then we said degree of 4. All right, the last one has a couple of steps involved. We've got distributive property first, and then we've got to add. So 2p squared, negative 2p squared times 4p cubed r. Minus 2 times 4 is minus 8. P times p cubed is p to the power of 4. Q squared doesn't have anything else to combine with, and neither does r, so it tucks in at the end. All right, that's that first part done. 3r squared times 7 is 21r squared, and minus 6r squared times 7. Now I could have combined these two first, I'm realizing, so they're both r squared, so I could have subtracted first, but let's just go with it. Minus 6r squared times 7 is minus 42r squared. So that'll be minus 8p4q squared r minus 21r squared. Nothing to combine in these, and then we just go to degree. So 4, 2, 1, add those together, we get a degree of 7, and 21r squared degree of 2, so this one has a degree of 7. Okay, so that is degree. It's not something that is going to be like ultra important in this particular lesson or in the practice that follows it, but it is going to come up and it's definitely going to be on your checkpoints and your unit test. So just make sure that you are kind of getting that in your head. Okay, what does degree mean and how does it work? If you want additional practice on adding, subtracting, or multiplying polynomials, I put some page numbers down the bottom that you can do in your textbook. I do recommend doing the extra practice because it's not going to be part of your practice work for this lesson. So if you want to practice this particular skill, those are the pages I recommend you do, but I'm not going to make them formal homework because you've got enough to do as it is. So what I want to draw your attention to here are the different parent functions that we can have for x and what they look like when you graph them. So, over here in blue, we've got a quadratic. So that's y equals x squared. In the kind of purpley red, we've got, let me draw an arrow to it. This is x to the power of 4. Now notice the difference. It's like a quadratic. It comes down. It doesn't cross the axis in more than one place, but it kind of like flattens out a little bit more as it gets to that 0, 0 point. And then in green is x to the power of 6. So even more so, like it comes down actually at a steeper rate of change than x squared does, but then it gets towards the axis and it dramatically flattens out and then goes back up again. So just be aware, okay, this is what some of those shapes might look like. On the other side, we've got, in purple, we've got x cubed. In black, we've got x to the power of 5. And then in red, we've got x to the power of 7. So notice again the difference in shapes. X cubed comes up, turns, goes back up again. X to the power of 5 comes up a little bit steeper, goes flat for a little bit longer, and then goes up again. And x to the power of 7 even steeper again, flatter, and then up at a steeper rate once more. So just keeping an eye on those shapes. Now notice the common things. Anything that was an odd number, so 3, 5, and 7, has that N shape. Anything that was even, 2, 4, 6, 8, has that U shape. And I say U-shaped because it opens upwards in all cases. So if you see one that opens downwards, you know that there is a negative a value involved. If you see an odd degree function and it's got an n shape the other way, a reverse n, then you know there was also a negative a involved. So just some things to watch out for. So we're going to write the equation of polynomials based on its roots. Now, in this case, I don't care very much about the turning point. So like what we're not trying to get the a value correct unless we're going for positive or negative. That's the only thing we would be concerned about. So when I look at the first one in green, we've got roots at -3, so -3, -2, and +1. So the solutions are -3, -2, and +1. And this one does look like a standard cubic, so it's got that classic N shape. So the a value is positive at least. So I know it's a positive a. We're going to assume it's 1 in all cases, just for now. A little bit later, we'll try and do a bit better in terms of getting the a value correct, but for now, we're going to assume it's 1. So I just want you to get the positive or negative part right. If -3 is a solution, well, that would mean, let me do this. So x is equal to -3. Remember, the factor is when it's equal to 0. So I'd add 3 to both sides. That means x plus 3 equals 0 is my factor. So if we were to write the equation in factored form, if the 0 is -3, one factor is x plus 3. If a 0 is at -2, factor is x plus 2. And if a 0 is at +1, then the factor is x is -1. And we had an a value of +1. So this would be my equation. Now, we will eventually get to a point where I'll ask you to distribute it, but for now, I'm cool with you leaving it in factored form. So just writing the equation of the graph in factored form. So if you type these 3 factors into Desmos, you will get the polynomial that looks like this one, the cubic function that looks like this one. The a value is 1 in all of these cases, so I didn't change it when I made this. Looking at the second one. Now, it's a different shape. The n is backwards, which means I'm expecting a negative a value. My roots are still the exact same numbers, though. So it's x plus 3, x plus 2, and x minus 1. So by just changing the negative, it changes the shape of the graph by reflecting it over the x-axis. So you just need to keep an eye out for what should the shape look like in the parent function, and then if it's different, am I expecting a negative a value or not? Like, what could be a reason for it? Going into the third one. Now this one has 1, 2, 3, 4 roots, but it opens upwards. So degree of 4 has that, we'll call it a U shape, and I've got quotation marks going on even though you can't see it because there is this like little kind of squiggle bit going on in the middle there, but it does open upwards, which suggests a positive a value. So even degree should open upwards, odd degree has got that N shape. All right, so then we would say y is equal to positive a value, so don't have to worry about that. My roots are at -3 or -2, -1, 0, and 4. So for -2, that would make a factor of x plus 2. For -1, x plus 1. For 0, it's just x, or x plus 0. And then for 4, x minus 4. That's it. That's all I'm looking for from you guys at the moment. So just what is the factored form and get your a value right. And then the last one over here, it's got that classic N shape. So it's a value of 1. We're expecting 3 factors because it's got that N shape. So it's a cubic, but we only see 2 roots. Now the key here is that the turning point is on the axis. And what that does, it means that there are actually 2 factors at that point. So by creating a x squared, so the factor is going to be doubled, it causes another turning point to occur at that point. So just to give you an idea, this would be the factor of x minus 1, or sorry, the 0 of x minus 1 means a factor of x plus 1, and then x minus 2. And what's happened is there is another x minus 2. That's what causes the turning point at x equals 2. So when you see the graph come down and be tangent to the axis, there are 2 factors there. So just keep an eye out on that. So this one has x plus 1, x minus 2, and x minus 2, or you could see x plus 1 and x minus 2 squared. Like either of those, they're the exact same thing. So just keep an eye out for that. Equation of a polynomial, or the one on the left is still the same idea. We've got 1, 2 roots, but it opens upwards in that U shape. This isn't a quadratic, so I should have, based on what I'm seeing here, I should either have 3 roots or 4, but it's not 3 because it's not a cubic look, like it's not that N shape, it's definitely a U shape. So that means that there must be 4 roots. So that tells me that at this point here, because it's got that kind of cubic look to it, this must be something cubed. So my solutions for this one would be y equals x plus 2, so to get that root at minus 2. And then we've got x minus 1, x minus 1, x minus 1. So there's 3 of them, and that's what causes that cubic, mini-looking cubic right here. So when it was in the last slide, when it did the little tangent, I mean, if you think of that in isolation, that's a little quadratic, so that was the point squared. Point cubed, you get a mini cubic at the point of intersection, or where it hits the x-axis. Now let's look at the other side. So we're going to graph these. So I'm going to probably graph it and then erase it. Roots or factors of x plus 1, x minus 1, that means that the zeros are at minus 1 and positive 1. If you were to multiply this out, there's an x in this one, an x in this one, so that would be an x squared is the highest one. That's a quadratic, so I'm expecting a U shape or an N shape. The a value is 1, so it should be U-shaped. So it's going to come, this is terrible drawing, I'm sorry, let me do that again. But we are sketching graphs at the moment. Like, I'm not trying to put actual points in here. All I care about at the moment is the 2 zeros being in the right spot, and I've got the right general shape. So it's going to like come down, turn, and go back up again. Like, that's what I mean by like sketch a graph, that you get the zeros right and you got it turning and you got a general right shape. So then we go to the next one. And we've got 3 factors. So x minus 2 means positive 2 is a 0, minus 3, and minus 5. And this one, so you've got x times x times x, so x cubed is our highest, so we're expecting a cubic shape. So starts low on the left, finishes high on the right. So it's going to come, up through that turning point, it's going to turn, go back down. Because there's more space between these, the turning point will be a little bit lower, and then it'll go back up again forever. Like, that's what the graph of that would roughly look like. So by sketching it, I don't know if my turning points are correct, but this is what I would expect it to look like. So above the line between the first 2 zeros, below the line between the second 2, and then finishing high, finishing low on either side. So end behavior is that word we're looking for. So the end behavior of a cubic should be, as x goes towards negative infinity, y goes towards negative infinity. As x goes towards positive infinity, y goes towards positive infinity, unless the a value is negative. All right, the third one, we've got x squared and x plus 2. Remember, x squared is the same as x plus 0 times x plus 0. So it just means that there's going to be a turning point, a 0 at x equals 0, and then x equals minus 2. Now, because there's 2 x equals 0s, that's in fact going to be a turning point. So this is a cubic, so we would end up with an x cubed if we were to distribute this, and that'll be the highest degree of x. So it's going to come up, it's going to turn, and then it's going to turn back up again at x equals 0, so something like that. So it's going to hit the 2 points, but it's going to be tangent at 0 because there's 2 factors for x equals 0. All right, the fourth one. We've got 4 factors, so that's going to be an x to the power of 4. So the parent function, remember, was it looks like a quadratic, but it's a little flatter, and then it goes back up again, but it is a U shape. But it's a negative, so now we're expecting more of an N shape. So it should open downwards. The zeros are at 3, 1, -2, and -4. So it's got that general U shape, so it's going to start at negative infinity. It's going to come up. It's going to turn, go back down, turn, go back up, and turn, go back down again. So it actually ends up being an M shape as opposed to an N. And yeah, that's what you're looking for. So you can always put these in Desmos to check your answer. It does not need to be perfect, but the zeros do need to be perfect, and the general shape needs to be perfect. The actual y coordinates, not as important. Like I don't care. I don't know if that's where they actually turn or not. I don't really care. I care about the zeros and the general shape, that you know what it's supposed to look like. And the idea is that you are able to do this without checking it on a calculator. So you can just recognize, okay, this is what I would expect it to look like. All right, take a shot at writing the equation for each of these. So we've got zeros at -3, -2, and 1. And on the other one, -4, there's a turning point at 0, and then there's an intercept at 2. So can you try and write the factored form of each of those in the space on either side, or on your own piece of paper? Come back, let's see how you did. All right, so we've got zeros at -3, -2, and 1. So factored form, it does have that classic N shape, so the A value is positive. We've got x plus 3, x plus 2, and x minus 1. So that will give me my 3 zeros and the A value, so I will get that N shape. Check your work in Desmos, see if it looks right. The one on the right-hand side then, zeros at -4, 0, and 2. But the one at 0 looks like it's a turning point, so it's going to have 2 factors. Now, this is what we call a multiplicity of 2. So there's a factor that it's repeated. So we've got x plus 4, and then we've got x, but we've got another x, so we would say x has a multiplicity of 2. So multiplicity ITY of 2. And then the last one, x minus 2. So again, try it. Type that in Desmos, see, are you right? But the double x causes a turning point at x equals 0. So we would say multiplicity of 2. In our previous example where it came up, and then did a little cubic in that space, that root, what I think it was what, x plus 1 or x minus 1 maybe, it had a multiplicity of 3. So that factor was repeated 3 times. So that word multiplicity just means the number of times a factor is repeated. All right, your turn again. This time you're sketching the graph based on the factors given to you. And notice that in number 2, x plus 1 has a multiplicity of 2. It is squared, so that factor is repeated. So check what you think the general shape should look like, then move it onto a graph with the roots in the right spot. Come back, see how you did. Okay, so zeros, x plus 3, x plus 2, and x. So we've got -3, -2, and 0. -3, -2, 0. If you multiply that out, x cubed is going to be your highest, so I'm expecting that cubic classic N shape. A value is positive, so it's going to stay the classic N. Going to come up from the bottom. Quick turn, go back down, quick turn, go back up, and finish. So we're also being asked to identify domain, range, and end behavior. So domain, negative infinity, positive infinity, range, negative infinity, positive infinity, end behavior. As x goes towards infinity, y goes towards infinity. As x goes towards negative infinity, y goes towards negative infinity. Second one, we have negative. So keep that in mind, whatever the shape is, we're going to flip it. X plus 1 squared, x minus 3, x plus 2. So that would be a highest degree of x of 4. So I'm expecting that kind of U shape, or it'll probably turn into a W. So that'll be 3 turning points. At x equals negative 1, there's a multiplicity of 2. So it's going to be a turning point there. So we've got zeros at minus 1. And this is the one that's a turning point. A 0 at 3 and a 0 at minus 2. Okay, so because it's that W shape, the negative causing that, it's going to start from the top. It's going to come down. Quick turn. Now, because minus 1 is a turning point, it's going to just hit the axis there, come back down again, and then go back up to finish that W. So it should be like a nice smooth curve. Like it's never going to be like a absolute value kind of idea, but just try and give some semblance to a smooth curve when possible. And then as for domain, range, and behavior, domain, negative infinity, positive infinity, range, you're approximating in this case, so it would be the lowest value would be included. So we'll just like pretend that it's going down here. So it's whatever that minimum value is. So we'll say minus 3.5. And it goes up to positive infinity. So really that's what I'm looking for, is like, do you recognize what the range should look like if you were given actual values? And then end behavior, as x goes towards positive infinity, y goes towards positive infinity, x goes towards negative infinity, y goes towards positive infinity as well. So if the degree is even, the end behaviors will match, either both going positive or both going negative. If it is odd, you'll have one of each. And it just depends on if it's been reflected or not. So typically it'll be like your standard one will be as x goes to positive infinity, y goes to positive infinity, x goes to negative infinity, y goes to negative infinity. But if the a value is negative, then the two of these would trade places. All right, so that brings us to the end of today. Essential questions. How to identify the roots of a polynomial and write it in factored form? You look for the zeros. So where does it cross the axis? And then for each of those, if you need to write the equation for if the 0 is minus 1, then you would say x equals minus 1, but you need it to equal 0 to be a factor. So you would bring the 1 over, it changes sign. So most of us recognize it as the factor and the 0 have opposite signs. If it's a fraction, that's when I would be a little bit more like solve it as an equation. So get it equal to 0 and then write out your factor that way. Writing it in factored form, so things to look out for if there are turning points on the axis. So if you see the function turn with a point of tangency on the axis, then that means that there's going to be multiplicities on that particular factor. So either it's going to be a factor of 2, 4, 6, 8 if there's a turn on it. If it makes a mini cubic look, then we're expecting multiplicities of 3, 5, or 7. So it's doing more. There's more factors at that point than just the one. Degree of a function is the highest sum of the exponents for each term, and the degree of the expression is equal to the highest one. So in our polynomials unit, we're not really going to have a mixture of variables. It's almost always going to be x or a's, but like it'll be consistent. So the degree is going to be equal to the highest exponent of x. So quadratics, cubics, powers of 4, and so on. Multiplicity, we talked about this a couple of times now. That is how many times a factor is repeated. So how many times the factor repeats itself in the factored form. So multiplicity of 2 means that that particular factor occurs twice, 3 times, and so on. At the end of today, you should be able to complete the module 1 folder. So this is other types of polynomials. So there's only 2 lessons in it this week. Next week, we'll do the 3rd lesson and the checkpoint. So you don't have any math tests to do this week, just those 2 lessons because you had a unit test as well this week. In our independent practice, you have a choice between Khan Academy and textbook. There are 2 Khan Academies or a decent amount of textbook questions. You get to choose which one you want to do. Again, I always kind of push the Khan Academy a little bit because you get that instant feedback and you get to really see some other instructional videos, you get hints, and you get to know, all right, what do I got? Do I have it or not? So do one of those, get it all done by Friday, and I will see you next week.